And to find the output of this, it's going to be a little bit of a thought question. This is what the voltage, this is what the circuit is, right? And we know what VC is. And if we know what VC is, and we know that this voltage between here and here is 0, right? No matter what the time region is, this is always 0 volts. Because there's negative feedback, no matter what the time region is, this is 0 volts. And since this is 0 volts relative to this ground, and this is VC relative to this ground, we can easily find what this current is. I'm going to call it I1. I'm going to solve this problem, step 5, to find what is V naught equal in a few sub-steps. The first sub-step, A, is to find out what is I1. And what I1 is going to be VC minus 0 on this side over 2. And we know what VC is. That we already found it up here. So I'll just simplify it as VC over 2, and we can later on plug VC into this. So that's this current. For any time greater than 0, it's this. It's this divided by 2. Our second step is to say, what is this current, I2? Well, I1 can't, none of it can flow into this op-amp. All of it has to flow through the 24 ohm. So that means I2 has got to be the same as I1, which we just said was VC over 2. The third step is to say, we want to find V naught. And it's great that we know I1 and I2, and it's great that we know the inputs are 0, but how do you find V naught? And the answer is we're going to say I2 flowing in this direction means we know that voltage. I'm going to call that voltage V24. We know what V24 is. It's got to be equal to, by Ohm's law, just I2 times 24. Right? We've defined it the right way. We've defined it entering more positive and exiting more negative. And interestingly enough, we already found what I2 is. It's equal to VC over 2. So just plugging in those two things, substituting in what I2 we already found is here, that's the whole thing is equal to 12 times VC. So if we knew what VC is, and we already found it here, multiplying it by 12 tells us what the voltage is across this. And that's really close to the voltage at V naught. In fact, we can figure out what the voltage at V naught is. We know that this is 0 volts. We know that this is, by definition, V24 less than here, but this was 0. So this voltage here has to be 24 volts less than 0. And that is this voltage. Let's just talk about that again. V naught is equal to this voltage minus V24. What this is saying is that this voltage here is 24 volts less than this voltage, but this voltage we say is 0. So this voltage has to be minus V24, and that's the same as V naught. If you didn't see that, let me write that first. V naught is equal to minus V24. So it's equal to minus 12 VC. If you didn't see that, I approached that intuitively. You could also do a KVL around there. You could also do a KVL right around here. You know what this voltage difference is. It's always going to be 0 volts between the inputs. We said that's the rule of negative feedback. So now let's just do a KVL right around here. 0 plus 0. So we're so far at, I'm solving the same thing in a different way. 0 plus V24 plus V24. You hit that plus first, plus V naught equals 0. And now we're back to where we started, 0 plus V24 plus V naught. So the solution for this, if we're solving for V naught, is this H equal to minus V24. So we found that in 2 different ways. Now we can finally solve our whole circuit because we know what VC is. We just multiply this by negative 12. So V naught times negative 12, we're just going to use this and substitute in what VC is here. So minus 12 times 5 over 6 is going to be minus 10. And minus 12 times 1/3 will be plus 4 e to the minus 24t, and that will be volts. And that is our answer to our problem.